This vision automatically generates an image with a bunch of words on it, and then actually introduces a noisy background, and then eventually actually rotates the words as well, as we're going to see here in a moment. So it automatically iterates through easy words first, and then medium words and hard words. Sometimes they overlap. And in parallel tests both GPT-4o's vision capabilities and the new 3.5 Sonnet's vision capabilities, and then writes them to a file. For example, this one is easy 10 without noise. Both Sonnet and GPT-4o got all 30 words correct because we did 3 iterations for each image. Here with noise, when we introduced words, GPT-4o got 29 right and 28 for Sonnet. But with noise and rotation, GPT-4o actually got all of it correct, and Sonnet got 28. With the hard, with noise and rotation, GPT-4o again got all of it right, while Sonnet only 28. And at the end, we have the final results. We see that GPT-4o actually did 99.6 correct, and Sonnet did 96.59. So this is not the whole story, obviously. This is just this test. But it's an interesting test, nevertheless. Let's run it again. This runs by this configuration here. We can actually increase the iteration configuration to 5. And we are testing 10 words per configuration. Let's increase it to 15. Let's delete these and run this again and see what happens. So now when an image is generated, it's the same image. Sorry, we're going to generate 5 different images for each category, as you're seeing. And then we're going to test it like that. By the way, I built this in an iterative way. The first file is just to generate the image, and then the second file is user input. The user controls this process manually, and the third one is the fully automated version. So the code files for this, the source code will be available at my Patreon. You can download it there by becoming a patron. If you do decide to become a patron, you not only get access to this project, but also 300 plus other projects. We will be reviewing the code shortly with a script that I've written, AI code explainer, right after we finish this test. So I hope this is clear. We just make it more and more difficult for AI. Let's see actually what happened with both noise and rotation. See again, Sonnet only got 94% correct here and 97% for GPT-4o. GPT-4o just seems to do better. Medium, let's see if we go to medium words with noise, they both did 100% correctly so far. With noise and rotation, again, GPT-4o seems to be ahead. So I've done this test several times, and this is the story I got. So I'll let this run, and I'll be right back when it's done. I guess actually, while we're waiting, I would like to mention my website real quick. If you are enjoying my content, you can find all my videos at my website, echohive.live. It is a convenient search. All of them here. There's quite a lot. And if you're a patron, you can also download the source code to each one of them. For example, the web researcher with task scheduler, self-instructing agent chatbot. I try to explore a new and interesting topic at least 4 or 5 times a week. Agent AGI is very interesting. So just take a look. And if you do decide to become a patron, I appreciate your support. So let's look at the final accumulated results. Again, GPT-4o did 98%, and Sonnet is behind at 96%. You can actually modify this and make the Pygame portion of the image generation different if you like. Also play around with the configurations as well. So, like I said, this begins by just using Pygame to generate words on an image. And then the second file, which we won't be reviewing the first 2 files, but at the Patreon download, they will all be present. The second one is user controlled. Let me actually delete these files and show you how it works. We are also saving the latest captures as well for testing purposes, perhaps. So if you run the not this, apologies, but the second one, then user controls inputs. there's some instructions here, and we can select, for example, let's select the hard uh, words. And how many words would you like to display? We can say 10. And then would we like a noisy background? Yes. Would we like the words to be rotated? Yes. And as you can see, this is the words. We can press now space to actually get this analyzed. And now we can press space again, and we analyze it, and the results are printed here. Again, GPT-4o seems to be doing better. Right here, again, GPT-4o is better. And then when we close this, results should be saved here. As you can see, it accumulates, and again, GPT-4o comes out on top, at least in this case. Okay, so now we're going to review the code, but the code will be reviewed by the script I've written, AI Code Explainer. Do let me know what you think of this. You can also download the AI Code Explainer as an architect member. And that's it. I hope you enjoy it.
This part of the code imports various modules and libraries necessary for the program. Pygame is used for handling graphical displays, while Random, JSON, and other libraries facilitate data manipulation and AI model integration. It initializes Pygame to prepare for rendering graphical content. Additionally, 2 AI models are defined, which will be used later for analyzing text images. This setup forms the backbone of our vision testing environment, ensuring all the necessary tools and configurations are in place before diving into complex functionality. Kind of like checking if you have all your ingredients ready before baking a cake. This segment sets up configurations for the vision tests, defining key parameters such as the number of iterations per configuration and words per test. Multiple test scenarios are prepared, varying in difficulty, noise, and rotation, to see how different conditions affect the recognition ability of AI models. This comprehensive setup ensures that the vision tests are methodically varied, challenging both the AI's analytical skills and possibly the user's imagination as they endure the words dance across the screen. This structured approach lays the foundation for the testing process, like laying out different workout routines that challenge various muscle groups. In this part of the code, we are initializing API clients for the AI models we're going to use. Using OpenAI and Anthropic clients, the program gears itself towards interacting with external AI services. If these clients initialize successfully, the code is prepared to send and receive data, making the AI models ready for analysis tasks. If there's an issue, the program gracefully exits. No point in continuing if our AI friends can't join the party. This crucial step ensures we're primed for predictive analytics, much like ensuring you've got snack deliveries from 2 different companies for your open day tech demo. This code snippet sets up the graphical display using Pygame. It defines the dimensions of the display window and sets the title for the window to random words display. 2 color constants, white and black, are defined for easy use later in the program, ensuring that word visibility doesn't end up being as mysterious as a black cat in a coal bin. A font is chosen for displaying text on the screen. This setup provides a visual platform for all the word positioning and graphical manipulations that follow. Here we define lists of words categorized by difficulty levels: easy, medium, and hard. This word selection is used in tests to challenge the AI models in identifying them under different configurations. The words in each category test different vocabulary complexities, ensuring the AI model's capabilities are well assessed. The max words variable ensures that any function working with words knows the maximum it should handle, preventing more words from being asked than can be safely managed. Kind of like setting a limit on the number of guests you can invite before your house becomes uncomfortably crowded.
I would like to take a moment to talk about the benefits of becoming a patron. As some of you may know, in the last year and a half, I've spent 3,000 hours, over 300 projects. As a patron, you will have access to all the code files so you can get inspiration and iterate quickly. Another benefit is that you'll have access to all my courses. And my most recent and most proud one, the 1000x Masterclass, teaching what I've learned on how to code fast and efficiently. Also the Streamlit course and the Fast API course. In my Patreon, I also have tiers in which you can connect with me one-on-one. Check those out as well.
This class, Accumulated Results, is a crucial component for managing and storing results from the word recognition tests. It tracks the performance of the 2 AI models across various configurations, accumulating results over multiple iterations. With functions like add config result, save config results, and save final results, it effectively organizes and persists data in a structured way. This allows for comprehensive reporting and analysis, ensuring that all test data isn't lost faster than accidentally closing a 100-tab browser without saving. It's like the bookkeeper of the test process, ensuring every win and loss is recorded and evaluated. This series of functions allows the user to input preferences for their testing environment. Users can select the difficulty level, number of words to test, and preferences for added noise and rotations of words on the display. Each function ensures that user input is safe and valid, catching errors and guiding the user with friendly prompts. It provides a customizable testing experience, like allowing users to choose toppings for their pizza. Everyone gets to enjoy it in their way. The generate noise function creates a visually noisy background using NumPy and Pygame. It employs random noise and sine wave patterns to simulate a dynamic, visually complex background that can challenge the AI model's recognition capabilities. RGB channel shifting further enhances the noise effect, like swapping color channels in an old TV. The final noise image is scaled to fit the screen, ensuring full coverage without disturbing our spatial imagination. This function generates random positions for words on the screen. It selects a random subset of words from the list according to the difficulty level and assigns a random position to each word within the bounds of the screen. If rotation is enabled, it also calculates space for rotated displays. This method ensures that words are displayed randomly, enhancing the randomness of our graphical puzzle, akin to scattering a puzzle on a table before assembling it. The function contributes to creating diverse visual scenarios that the AI needs to process, testing its ability to adapt to different visual setups. The test results class encapsulates individual test result management. It tracks the accuracy of each AI model's word detection during a specific testing configuration, storing both correct and incorrect responses. Methods like add analysis and get results compile and store these statistics, providing a detailed look into model performance under specific conditions. This class acts as the high-tech clipboard of results from each test session, ensuring all data remains as neat and organized as a librarian's desk after hours. Its careful tracking ensures no learning opportunity is lost in the shuffle. This asynchronous function captures the screen image of the current display to analyze it with AI models. After ensuring the display is ready to be captured, it saves a snapshot as a JPEG file. It then encodes this image to base64 for transmission to the AI model's APIs for analysis. This part is like asking a friend to check if your selfie game is on point, capturing, packaging, and sending for assessment by AI models. The process uses asynchronous execution to efficiently handle concurrent requests, streamlining the workflow. This function sends the captured screen image to the Claude AI model for word extraction. Instructions embedded in the request guide the model on how to process the image, focusing solely on identifying and returning visible words. The response is then cleaned to extract only the relevant data, detected words. This function extracts useful information while handling errors gracefully, like a polite cat burglar who returns home with feline finesse, taking only the essentials. The async method enhances the program's performance by handling tasks concurrently. This function mirrors the logic of analyzing with Claude, but this time it's handling the GPT-4 model. The function sends the image as a base64 URL, and the model processes the image to retrieve visible words. The response is parsed to focus on the actual data received, detected words, keeping outputs succinct and relevant. Handling the response similarly for both AI models maintains consistency, ensuring the AI's evaluations are compared fairly, like a fair judge rating contestants in a talent show while discarding any extra unsolicited explanations. The main function orchestrates the vision test by iterating through defined configurations, managing how the tests are conducted, and handling results. For each configuration, it generates word displays with varying parameters like noise, rotation, and difficulty. After presenting words, it captures and analyzes the display, updating results akin to a game show host eagerly tallying points each round and calling it a night by saving the final results to disk. This method creates a seamless flow of operations, managing tests and results efficiently, ensuring our vision testing efforts wrap up with a neat and tidy report ready for evaluative gaze.
I would like to take a moment to talk about the benefits of becoming a patron. As some of you may know, in the last year and a half, I've spent 3,000 hours, over 300 projects as a patron. You will have access to all the code files so you can get inspiration and iterate quickly. Another benefit is that you'll have access to all my courses. And my most recent and most proud one, the 1000x Masterclass, teaching what I've learned on how to code fast and efficiently. Also the Streamlit course and the Fast API course. In my Patreon, I also have tiers in which you can connect with me one-on-one. Check those out as well.
Now, listen to me. I've been trying to code, and I like coding. The fact that I can code and make things happen, but how do I do it? I mean, fast with AI. I'd heard about it. It's easy. So, I came across 1000x cursor course. And that's great, it just made everything super silky smooth. It just worked. I'm telling you.
1000x your coding.